Good day, everyone! Welcome to my YouTube channel. It's me, Sir Bart, at kung bago pa lang sa aking YouTube channel, please subscribe and click the notification bell for more video updates. And today's discussion is all about the 6 trigonometric ratios. Now, let's review what are the parts of a right triangle. Let's recall that a right triangle is a kind of triangle that has one right angle and two acute angles. The hypotenuse is the opposite side of a right angle, which is the longest side of a triangle. We have a triangle, and let's name our triangle triangle A, B, C. Of course, we have the theta, which is the reference angle, and the symbol for a right triangle. The opposite of a right triangle is what we call the hypotenuse. And the two legs of our right triangle is what we call the opposite side, which is the opposite of our reference angle. And the adjacent side is an adjacent side of a reference angle. What is reference angle? Reference angle is the acute angle between the terminal side and the x-axis. Reference angle is always positive. It is indicated by the symbol theta. Angle C is the reference angle in triangle ABC. Next is the opposite side. It is a side across the reference angle in a right triangle. Segment AB is the opposite side of angle C. Next is adjacent side. The side next to the reference angle in a right triangle. Segment BC is the adjacent side of triangle ABC. Hypotenuse is the longest side of a triangle. It is always opposite of 90 degrees angle in a right triangle. In triangle ABC is the hypotenuse is segment AC. Are you familiar with the word SOHCAHTOA? What is SOHCAHTOA? SOHCAHTOA, it is a mnemonic used for remembering the equations. Notice that the three new ratios at the right are reciprocals of the ratios on the left. So we have now a triangle and its part, the hypotenuse, opposite side, and adjacent side. SOHCAHTOA stands for sine theta is equal to opposite over hypotenuse. Cosine theta is equal to adjacent over hypotenuse. Tangent theta is equal to opposite over adjacent. Cosecant theta is the reciprocal of sine theta, which is cosecant theta is equal to hypotenuse over opposite. And secant theta is the reciprocal of cosine theta, which is secant theta is equal to hypotenuse over adjacent. And cotangent theta is the reciprocal of tangent theta, which is cotangent theta is equal to adjacent over hypotenuse. Let's try this example. Illustrate the 6 trigonometric ratios of triangle MAT. Let's start with sine theta. Sine theta is equal to opposite over hypotenuse. And the opposite of our reference angle is T, and the hypotenuse of our right triangle is A. Sine theta is equal to T over A. Cosine theta is equal to adjacent over hypotenuse. The adjacent of our reference angle is M, and the hypotenuse of our right triangle is A. Therefore, cosine theta is equal to M over A. Tangent theta is equal to opposite over adjacent. The opposite of our reference angle is T, and the adjacent of our reference angle is M. Therefore, tangent theta is equal to T over M. Cosecant theta is equal to hypotenuse over opposite. The hypotenuse of a right triangle is A, and the opposite of our reference angle is T. Therefore, cosecant theta is equal to A over T. Secant theta is equal to hypotenuse over adjacent. Secant theta is equal to A over M. Cotangent theta is equal to A or adjacent over opposite. Cotangent theta now is equal to M over T. Let's try another example. Illustrate the 6 trigonometric ratios given the following measurement of triangle KIM. Let's start with sine theta. Sine theta is equal to opposite over hypotenuse. The opposite of our theta is 6 and the hypotenuse of our triangle is 10. So we have sine theta is equal to 6 over 10. Or reduced into its simplest form, 6 over 10 is equal to 3/5 or 3 over 5. So the final answer of sine theta is equal to 3 over 5. Cosine theta is equal to 8 over 10. Or reduced to its simplest form, we have 4 over 5. Tangent theta is equal to opposite over adjacent. 6 over 8. Reduce 6 over 8 is equal to 3 over 4. Tangent theta now is equal to 3 over 4. Cosecant theta is equal to 10 over 6. Reduce 10 over 6 is equal to 5 over 3. Secant theta is equal to 10 over 8. Or reduce 10 over 8 into 5 over 4. And the last one, cotangent theta is equal to 8 over 6. Or reduce 8 over 6, we have 4 over 3. Cotangent theta now is equal to 4 over 3. That's all. Thank you for listening.